हेलो डियर स्टूडेंट्स, आज के इस लेक्चर में हम बात करने जा रहे हैं विद रिगार्ड टू स्पेसिफिक एंगल ऑफ रोटेशन एंड एनांटियोमेरिक एक्सेस। हमारे पास एक लाइट सोर्स है सोडियम लैंप का। When this light is passed through a polarizer, we are getting a plane polarizer light. That light when passed through sample cell containing the solution of chiral molecule, and this chiral molecule then rotates that PPL either clockwise or anti-clockwise. अब कितना ये rotate करेगा? How much it's being rotated? So जो वहाँ पे angle बनेगा we call that angle of rotation. So we can say angle of rotation is actually an angle by which a chiral molecule rotates plane polarized light. That's called as angle of rotation. It is denoted by theta. This angle of rotation depends on two things. Number one is the concentration of solution of that chiral molecule and length of that tube in which the solution is placed. So we can write theta is directly proportional to concentration C and length, where C is the concentration of solution of chiral molecule in gram per ml and L is the length of tube in decimeters in which the solution is placed. So point to be noted is that the units of concentration is grams per ml or grams per centimeter cube, and L is the length whose unit is in decimeters. Now, so remove the proportionality to equality, you are getting theta will be equal to alpha into C into L. This alpha is the constant of proportionality called specific angle of rotation. We can write alpha equal to theta divided by C into L. This is the equation which is used to calculate the specific angle of rotation. In addition to the concentration and length that angle of rotation depends on, it also depends on solvent in which solution is made, and temperature, and the wavelength of light used. So we can write alpha as subscript lambda indicates wavelength used, and T is the temperature at which the process is carried out. Usually जो आप लाइट इस्तेमाल करते हैं वो सोडियम की होती है, दैट्स कॉल्ड एज सोडियम डी लाइन. उसकी वेवलेंथ जो होती है दैट्स 589 नैनोमीटर्स. नाउ इफ angle of rotation, concentration and length is known, you can easily calculate the specific angle of rotation. Now we have another concept, that is enantiomeric axis. What do you mean by enantiomeric axis? आपको पता है when you have 50% R isomer and 50% S isomer together in a mixture, we call that mixture as a racemic mixture. This racemic mixture is optically inactive because अगर R isomer rotate करेगा PPL to right, S isomer जो इसमें है वो rotate करेगा equal amount to the left. The net result is it won't rotate the PPL at all, therefore it will be optically inactive. However, अगर percentage में deviation आएगी, then it leads to enantiomeric excess. So we can write if percentage deviates, it leads to enantiomeric excess, and hence mixture will be optically active. For example, if R isomer is 60% and S isomer is 40%, then enantiomeric excess will be equal to percentage of R minus percentage of S. That gives you 20%, and this will be R because R is in greater amount. If S would have been in larger amount, then enantiomeric excess will be equal to percentage of S minus percentage of R. So bigger one you have to kept first and then the smaller one. I hope you understand it. Enantiomeric excess अगर आप represent करेंगे in decimal form, we call that optical purity. So we can write optical purity is basically the enantiomeric excess in decimal form. So we can write 20% as 20 by 100. That gives you 0.2. That's called as optical purity. Now, if instead of percentage, masses of R and S is given, then the way to calculate enantiomeric excess is, so we have enantiomeric excess equal to R minus S divided by R plus S multiply 100. For example, we have 16 grams of R and 14 grams of S in a mixture. So how can you calculate enantiomeric excess? You have the above formula, that is enantiomeric excess is equal to 16 minus 4 divided by 16 plus 4, that's 20, multiply 100. That gives you 60% enantiomeric excess. Since R is more, that is 16 grams, therefore it is 60% R. However, अगर ना percentage दी हुई है ना masses दिया हुआ है, if observed rotation is given, then enantiomeric excess will be equal to specific rotation of sample divided by specific rotation of pure enantiomer multiply 100. This is illustrated as, suppose we have a sample of 2-bromobutane, that's a chiral molecule. It's having an observed specific rotation of plus 9.2 degree. If the specific rotation of its pure S enantiomer is plus 23.1 degree, then enantiomeric excess is. So you use the equation enantiomeric excess is equal to specific rotation of sample divided by specific rotation of pure enantiomer multiply 100. That is equal to plus 9.2 divided by 23.1 multiply 100. That gives you 40% enantiomeric excess. Now, in optical purity will obviously be equal to 40 by 100, that's 0.4. If the concentration is given in moles or millimoles, accordingly you can convert that into percentage and find the enantiomeric excess of that mixture. I hope you understand it. If you like my videos, please do not hesitate to subscribe my channel. Thanks for watching DHC.